Yeah, hi, my name is Farid. This is again a quick, or rather, tips on how to let a boat or something float on moving waves for example, in ocean waves or something like this. So, boat or any kind of object that you want to let float on the surface and follow the movement of the waves. So, there's many ways. We're going to show you the simplest way and very efficient way. I'll show you first thing what I'm talking about. This is kind of how to let something kind of very um, natural movement of the boat, like something like here. You can see that follow the waves and just try to match the. So the first thing, the well-known method is using the LBD. So you simulate a low resolution movement from a boat, and then you transfer it to a high resolution one. So in this case, you just take some wave tank, very small, with very small grid scale, so something like zero point 0.3 with the scale, and then you simulate it as an you just use the boat or the object you want to float as LBD as an LBD object, which you can bring from here also directly, so without the LBD hero object. And in the very important thing here to remember is to go to the flip solver, and in the solver you have to enable the feedback scale. So the vector diff is 0, so you have to put it in 1, and then you play with the some physical property. You untick the compute center of mass, because we want to find the mass. It's very, very difficult to get it to work in the first place, because you need some iteration to get the right center of mass, because when you change it by hand, you have to find it, and also rotational stiffness and the density. So you have to play with these three parameter in order to get just have to iterate until you find. And because it's very cheap simulation, you can iterate quickly, as you can see, the particle separation, you can put it on high. We don't want really a collision or something like that. We just want to calculate the feedback scale. The feedback scale, so that it gives us a natural movement. And after that, you bring again the simulated point, because you as I bring the board again and transform it, use it, assemble it again. Then I import the the LBD simulation, the flip solver simulation, not the LBD, the flip simulation. But I want to just import the point to represent object. You can also, I think. You bring the point as you bring the object as a point, you can see, and then you write it as a file, and then we are going to use it to transform the pieces. In this case, the boat, just bring a file and use the transform pieces with the match attribute name, and do the same for the VDB, but because it's moving, so I did. It's a very older project, so but normally we have to do a VDB inside, and then use again transform pieces, the same transform pieces, just to transform the ABD, so you don't have to write all the as I did here. So I write a big file. You just write it one time, one VDB, and transform pieces with the same animation, with the same point that you simulated with the flip. And after that, you are you write it on due to some, I did some time blends to get some smooth movement, and then this is what we are going to feed into the high resolution simulation. So in this one, and of course the VDB that we generate from the moving boat. So, and then we go to you can see here, I just same setup, we just have a big guided ocean layer, with some extra knowledge, as you know. So we merge it here and we do our work and same things with a higher simulation. What is this? With a higher simulation particle separation, so that we get the higher. And you feed this the static board, and everything should work exactly as you expect. But this is not our so let's show you another method, which I think it's very easier. It's a little easier than the other one. So to get started, we get an object, or I just want copy from another, so that we spare some time. I can bring one object, which it's just let me auto update. Yeah, it's calculating. It's rendering by rendering another project. That's why it's taking time to update the viewport or to wake up Houdini. Anyway, all right, there we have it. We first thing you have to do is so I set up just a grid. You can see a simple grid with some division, just to see the displacement detail. So first thing is you use a UV texture. Just take an UV texture and orthographic and project it in y-axis. So just we have what is called UV texture, and sometimes it comes in this case, and I just want to think -1 will do it. Or I forgot how -1 will do it normally. Or maybe anyways, that doesn't just want to flip it here. I forgot how to flip it. Maybe this one. Yeah, this one. Yeah, but we don't do this, I don't need to flip it or something like this. But if you want to flip it, you know how. Then we with the ocean spectrum, yeah, as you know, and then ocean evaluate. So in the ocean spectrum, well, some changes I did just to get some movement. I don't want to see the UV, but the UV is very important. Don't forget it. So we can play the animation, as you can see. Let me. So and now we bring some kind of board, some kind of board. I don't have didn't take the board, but let me change the orientation here. Okay, and I did a mistake, so let me oh, sorry, don't want it to. All right, so we have some box floating inside. I want to make it float, so I have double things. I want to put so that we can see it better. All right, first thing you do is you bring something called sticky in Houdini. When you tip sticky, you get something like this, and in this sticky, we want to get the ocean evaluate in the stick geometry. So I mean where I have to stick it. So I just want to go to the this is the ocean evaluate and I can let me put it inside, but I just want the ocean evaluate so that I can get. But let me shut up this so that I can show you what is going on. You can see it puts some nodes. It was called the rivet in Maya. You can see it follow the movement of things. All you have to do is this is the box and this is the sticky. All you have to do is put the stick on the box, as you can see, and now it will stick on the. Of course, we change the orientation. So let me no 0. I want the rotation. Oh, something like this, and now it will move accordingly with the you can floating some kind of. Now if you want to make some animation, you have to play in the sticky node, you have to play with the UV. So I think the V axis, this is the one who's going to move the object. So we can, for example, set a keyframe here and go and move it a little bit, so something like this, and put the frame. So we just want to make it linear, something like this. So we don't have to see the ease in, ease out. As you can see, it's moving on the wave, very harsh. Yes, why? Because the we can do better. So first thing, because we can use a null, so that we can use a shop network to get some filtering on the waves. That you can see, I show you. So you put you kind of null here, you know, and we use a chop network. You know, in the chop network, we are going to import the object first, you know, and we of course we want to well, let me see, we want to import the, what is it, we want to import the sticky, so this one, and the sticky one is the object that we are going to see. This is where the movement are lying. So we go to the where is it? Yeah, let me show this one. As you can see, this is the, why I don't see, sorry, position and rotation. Position and the rotation, and now you can see the movement of that. You can see that's very hard, and you know, take a look at the waves. We can see the y-x, all the channel, as you can see, all the channels, scope all the channel. So, but we can do, what we can do, we can use some filter, you know, some filter just to tweak a little bit more of the node. So we just shut this one. As you can see the difference between this one and this one, and you can play again with some filtering to get rid of the something like this. And now you can put null, all right, and no, we call it something like out, and we export it. So export, we want to use the null that we did, okay, and when we go outside, you can see we have now the sticky, we can move it here, and if I go outside, you can see the movement is translated to the, and it's really a little bit smooth than the other one. But you can do better if you go inside. You can target any other channel, like you know, if I put something like I don't know, call it something like XYZ, I don't know. Then you go to the command and you target extra channel, for example RX, and you can see we see Y, something like this. And if we go outside and play with this, you know, you can see this is the wrong axis. So maybe it's the Z, maybe. Yeah, you can target the Z axis, and of course the X axis, I think, is the one that we need. As you can see, you can put it a little bit outside and, you know, play the animations. You can see it's too much. Maybe 10 or something. We just have to move so quickly. And again, you can use some filter the width, and you know, play with some filtering, and you know, some for each axis that you need. And after that, you can also put some delay node. You know, this delay node is a very interesting node. This one will you know, you can see what's it doing. If I can put some delay a little bit, you can see they don't follow exactly the movement of the wave, so they come a little bit late, too late, or too early. So in this case, we can get it's too much. I think yeah, I did too much movement there. You can see. Um, yeah, you can tweak it more when you have more time.